Okay, let's try to solve exercise number 12. Exercise number 12 from mechanics. Exercise number 12. Number 12. According to the condition, a solid homogeneous cylinder of mass m and radius r was set in horizontal motion was set in rotational motion around its axis with angular velocity omega 0. Angular velocity omega 0. And then it was placed with its side surface on a horizontal plane. The coefficient of friction between the cylinder and the plane is equal to K. Coefficient of friction is equal to K. Find the time period when the cylinder moves with slipping, and the work of the force of friction that acts on the cylinder. During this time. Okay, I will try to draw a picture to show the situation. So we have cylinder. We have cylinder on a plane surface. This is a plane surface. Cylinder on a plane surface, and there is also rotational motion, rotation of cylinder, rotation in this direction that is shown by this arrow. Okay, okay, and first of all, if we have this rotation, can we define the direction of angular velocity? Direction of angular velocity in this case. You can show this direction on the picture. The direction of angular velocity of rotation. It can be defined. With right hand rule. And according to this rule, angular velocity is directed from us to the screen. So we have this direction of vector of angular velocity. Okay, this vector is defined. And do you have any ideas how to solve this problem? And maybe in another way, what is the first step in solving every problem in dynamics? What is the first step? When we have the condition, when we have already understood the condition, and when we have drawn a picture, what will be our next step to solve this problem? And in another way, what do we need to know? What do we need to know to solve dynamics problem? Maybe we need to know forces, that act in our mechanical system. We need to know forces. Okay, and can you remember? Can you remember any forces, any force that may act in our system? Okay, no ideas. Uh, okay, so but first of all, we can remember. We can remember force of gravity, for example. Force of gravity. Uh, this force always acts on system that has mass. Force of gravity always acts on system with mass. So and the force of gravity is mg, where g is acceleration of free fall. Uh, and maybe there are some other forces in this case in our system. Maybe there are some other forces, and maybe you can remember them. Because in this case, if only gravity force is present in system, if only gravity force acts, this cylinder will fall down. But it doesn't. It doesn't fall. It doesn't fall down. It means that there is some another force. There is some another force that that may prevent cylinder from falling down. And what force is it? What force prevents cylinder from falling down? Maybe you can remember this. And we have learned a few lessons ago. We have learned different types of forces, and now we need just to remember them. Now we need just to remember these forces. This is a force of normal reaction. That is impressed on cylinder and acts from plane surface on cylinder. This is a force of normal reaction. Force of normal reaction. Force of normal reaction. Force of normal reaction. And maybe there are some other forces. Maybe there are some other forces. I will take a clue that this force is connected with rotation of cylinder. Rotation of cylinder causes this force. And which force is it? And another clue that we have coefficient of friction. We have coefficient of friction key. What does it mean? Coefficient of friction is always connected with one definite type of force. And what force is it that is connected with coefficient of friction? Maybe you can remember this. So what type of force is connected with coefficient of friction? Key in our exercise. It is force of friction. Force of friction. Okay, and maybe you can show on the picture the direction of the force of friction. So who can show on the picture the vector of force of friction? Nobody can. It's a pity. It's a pity. Force force of friction always tries to prevent slippering in system. Force of friction always tries to prevent slippering in system. So the direction of force of friction is another in relation to the direction of slippering. So we can draw this force. It will be here. This force will be here, but this bad picture. The force of friction. Force of friction. It will be here. This is a force of friction. This is force of friction. Force of friction. It is directed from the point of contact between the cylinder and the surface, from a point of contact to the right. So this F is a force of friction. F is a force of friction. Okay, and what can we say about these forces? Force of gravity we can calculate. It is m multiplied by g. G is acceleration of free fall, and g is a first letter of avert gravity, and n is normal reaction. N is normal reaction, and what can we say about the force of normal reaction? Force of normal reaction. Can we define this force? Can we define this force? If cylinder doesn't fall down, and it doesn't take off. The cylinder doesn't fall down, and it doesn't take off the surface. So in this case, what can we say about force of normal reaction? Maybe someone can think up this or remember how to define force of normal reaction. No one can. The absolute value of this force is equal to force of gravity. Is equal to force of gravity, because unless it is equal, cylinder will fall down or take off. Is if force of gravity more than normal reaction, a cylinder will fall down, and when normal reaction is more than force of gravity, the cylinder will take off, and because it doesn't fall down and it doesn't take off, nor absolute value of normal reaction is equal to force of gravity. Force of gravity is equal to force of gravity. Okay, and next question is how to define the force of friction. How to define the force of friction of this cylinder. Maybe you can remember Hamilton-Coulom's law of friction. And how to define force of friction for our system. Can someone remember this? How to define force of friction? No one can remember. Force of friction, the modulus of force of friction, is equal to modulus of normal reaction. Modulus of normal reaction multiplied by coefficient of friction T. T multiplied by modulus of normal reaction. Okay, and what will be the next step? What will be the next step? The next step will be substitution of this. So it will be K M G. So this is the force of friction. This is the force of friction. This is the force of friction. Okay, and how to what will be the next step? In this case, absolute values of normal reaction and gravity force and the force of gravity are equal, but we also have force of friction. We also have force of friction, and this force of friction, this force of friction will cause horizontal motion of this cylinder. It will this force of friction will lead to horizontal motion of cylinder with velocity v. Okay, and how can we define this velocity of motion of center mass of cylinder? How can we define this velocity for this system? Or maybe we cannot do this. Okay. Okay, so maybe you can remember the second Newton's law. The second Newton's law. Can you remember this? The second Newton's law. You can just write this on the screen. Maybe if it is difficult, because it is difficult to say, it is difficult to say this law, but it is quite simple. It is quite simple to write a formula. It's quite simple to write formula on the screen. The formula of the second Newton's law is well known. It is mass multiplied by the first derivative of velocity, and this is equal to F. This is equal to force. This is equal to force. Okay, and the next step is to make substitution, to use our force of friction that we have found before in our second Newton's law of motion. M dv by dt, and this is equal to kmg. kmg. This is equal to kmg, and from here we can divide left and right parts by m, because m is not equal to 0, so we can make division. We can make division, and we will obtain dv by dt is equal to key g. Is equal to key g. This is equal to key and g. Okay, and how can we find a velocity v from this equation? How define velocity v? How find velocity v from this equation? So we have to find v. We have to find v. How to do this? It is necessary to remember our previous lessons, and to do some things in the similar way, as we did on our previous lessons. In similar way on previous lessons. So the first step that we need is to separate variables in this differential equation. We have already done this before, so it is necessary just to remember how to do this. Necessary just to remember. Maybe someone can remember. Who can remember this? How to separate variables in this equation? Or maybe you can remember this from your math course. Separation of variables in a differential equation. No one can. Okay, so it means this we have to multiple left and right sides on differential t, and we will obtain dv is equal to k g kg dt. Okay, in this case, variables are separated. It means that we don't have differentials in denominator. And different variables are in different sides of the equation. So we have v in left side and we have t in the right side. Okay, so it means that our variables are separated. And it means that we can integrate this differential equation. We can integrate this differential equation. We can integrate this differential equation. Okay, and the next step is to define integral limits. To define integral limits. So I mean this integral limits, because if we don't do this, we will have undefined constant in our result of integration. In order not to obtain undefined constant, we need to define integral limits. Okay, so can you do this? Can you remember how to define integral limits according to the condition of the exercise? Okay, the lower limit uh, is initial. Here we have initial velocity. And what is initial velocity equal to? Initial velocity. What is initial velocity equal to in our case? It is equal to 0. It was equal to 0. So it is, and what is initial time? Initial time is also equal to 0. It is also equal to 0. And the upper limits will be any velocity and any time. Okay, do you have any questions about this? Do you have any questions about this? No questions. Okay, so the next step is to calculate these integrals. The next step is to calculate these integrals. Can someone remember how to calculate, for example, this integral? How to calculate this integral? Maybe someone can do this or not. Because it is quite simple math problem. Quite simple math problem. The only thing it is necessary to remember a little a little bit mathematical analysis or calculus. So it will be enough. It will be enough to calculate this integral, because it is simple. It is simple. The simple defined integral. The solution can be found in textbooks, in reference books, in the internet. So it is just only necessary to find the solution. No ideas. It's very bad. It's very bad because it is a very simple question. Because it is very simple question. So it will be just v, and v from 0 to v, and this is equal to v minus 0, and this is equal to v. This is equal to v. Okay, and what about the second integral? Integral from 0 to time t, kg dt, kg and dt. How to calculate this? I'll remind that k and g are constants. These values are constants. So how can we calculate this integral? Okay, and what can you remember about constant in integral? What can we do with this, with constant inside integral? But we can change places of integral and constant. It is also from your math course. So it will be kg integral from 0 to t dt. It will be this, from 0 to t dt. Okay, and what is the next step? What is the next step? This integral is very similar to integral that was before. So can we use this? Can we use this to solve this? What will we have here? What will we have here? These cases are very, very similar. very, very similar to each other. Maybe someone, maybe some of you can think of this. Maybe someone can have an idea how to solve this integral. Because we have very similar situation here. So very similar situation was solved before. So how to do this? Okay, it's a very difficult situation because there are no any activity. There are no any activity during the lesson, and I don't know how to graduate you at the in the end of the semester, because I need some activity. I need some activity to define grades. I need some activity to define grades at the end of the semester. So how can I do this? How can I do this if you don't answer any of my questions? So how can I graduate you? Okay, it will be K G T. T is equal to 0 and T is equal to T. It will be key. Okay, G T minus 0. K G T minus 0 and K G T. K G and T. K G and T. Okay, let's substitute these integrals. Sorry, it is not 0. It is definitely equal to V. So from here we have obtained that V is equal to K G T. V is equal to KGT. Okay, do you have any questions about this? Do you have any questions? No questions. No questions. Okay, if there are no questions, I will clean some unnecessary things. I will clean some unnecessary things from our screen, from the screen, and I will leave just the final result. The velocity of motion of the center of mass of the cylinder is is v, that is equal to kgt. So this is velocity v. This is velocity v. Okay, but it is not enough. It is not enough to solve this exercise. It is not enough to solve this exercise. So so how can we? What will be the next step? What will be the next step? Okay, the next step is the velocity of slippering. Is to define velocity of slippering. Velocity of slipper motion. Let's draw our cylinder again, and let's imagine that there is only rotational motion. Let's imagine that there is only rotational motion, that there is no any other motions, only rotation, only rotation with angular velocity omega, that is directed from us to the screen. Angular velocity. So direction of rotation is here. And what in this case we have radius of cylinder according to the condition. The radius of cylinder is r. Angular velocity omega. And according to this, what can you say about velocity of this point? Velocity of this point. What can you say about the velocity of this point? Velocity of this point. It will be directed to the left. It will be directed to the left, and we will sign this with VR. R is the first letter of rotation. So the velocity caused by rotation. And if we have both linear motion and rotational motion, both type of motions, from here we can define velocity of slippering. Velocity of slippering. So velocity v, velocity of linear motion is directed to the right, and velocity that caused by rotation vr is directed to the left. So it means that velocity of slippering is equal to v minus vr. V minus vr. Velocity of slippering is v minus vr. Okay, do you have any questions about this? No questions. No questions. Okay, if there are no questions, the next step is to define is to find VR. Velocity that is connected with rotation. It's connected to rotation. Maybe you can find VR from this picture. Maybe you can find VR from this picture. How to do this? How to find VR from this picture? Any ideas? It will be omega angular velocity multiplied by r. Okay, so now we need to dependence. We need to find dependence of angular velocity on time. How to find this angular velocity omega for in our situation? How to define this? How to define this? What it will be? It will be just we can find this from equation of rotational motion dynamics. From equation of rotational motion dynamics. So we have moment of inertia multiplied by first derivative of angular velocity, and this is equal to this is equal to this is equal to the moment equal to the moment of I will just write this in vector form. It is equal to moment of force. Moment of force. This is there is only one force that is not compensated. There is only one force that is not compensated. This is the force of friction. So this force of friction produces a moment of force of friction. And now the next step is to find this moment of force of friction. But first of all, we have to define the direction of this moment of force of friction. To define the direction of moment of force of friction. And can we do this? It is simple to do because moment of force of friction is directed against it is opposes rotation. So the direction of force of friction is from the screen to us. So this is direction of moment of force of friction. Moment of force of friction. So the directions of omega and directions of angular velocity omega and moment of force of friction, they are different. So it means that from here we have that direction of omega and the directions of omega and moment of force of friction are opposed to each other. And so from here we can say that we have we can write this law of rotational motion dynamics in scalar form. I omega dt is equal to minus m. We have minus because of these different directions of angular velocity and moment of force of friction. Okay, and the next step is to define moment of inertia of a homogeneous cylinder. We must know this from our previous lessons. Moment of inertia of homogeneous cylinder related to its axis of symmetry. Moment of inertia of homogeneous cylinder. Can you remember this? Can you remember this value from our previous lessons? Cannot. That's not well. It's not well, but I have nothing to do with this. It is equal to m multiplied by squared radius of cylinder and divided by 2. This is moment of inertia. Okay, and what about moment of force of friction? What about moment of force of friction? Moment of force of friction will be, according to this picture, will be m equal to f r, and this will be, as you can remember, f is equal to kmg. So from here we have k m g r. We have kmg r. We have kmg multiplied by r. Multiplied by r. Okay, so let's move this here. Let's move this here and let's substitute this moment of inertia and moment of force of friction into our equation of rotational motion dynamics. So it will be m squared r divided by 2 derivative of angular velocity and time. And this is equal to minus k m g r. Okay, this equation may be simplified. If to do this we have to divide left and right sides. To divide left and right sides by this multiplier. And after division, we will obtain this. Is equal to minus kg divided by r. Minus kg divided by r. Okay, and the next step is to find angular velocity omega from this equation. How can we do this? How can we find omega from this equation? Okay, we can separate variables. The situation is very similar. This is similar to what we had in this case. Situation is very similar. So I think we can do this. If you want to, of course. Okay, to separate variables, it is enough to multiple left and right sides by dt. So we have d omega is equal to minus k g divided by r dt. And when variables are separated, we can integrate this differential equation. So we can write integrals in left and right sides. We can write integrals. Minus k g divided by r dt. Divided by r and dt. Okay, and the next step is to define integral limits. And how to do this? How to define integral limits in this case? With time, the situation is the same to previous. So we have from 0 to t, and with angular velocity omega, the situation is a little bit different because according to the condition, we have initial angular velocity that is not equal to 0. That is equal to omega 0. It means that we have to define lower integral limit as omega 0, and upper will be just omega. Just omega. Okay, and after calculation of these integrals, they are very similar to that what we had before. So I will not repeat. I will not repeat these particular steps. So we will have first integral. First integral is first integral can be easily calculated. It will be is equal to omega 0 is equal to from omega 0 to omega. And of course it will be omega minus omega 0. Omega minus omega 0. And what about this? What about this? This is equal to integral from 0 to t minus kg divided by r dt divided multiplied by dt, and this will be minus kg divided by r integral from 0 to t Okay, and we have already calculated similar integral, and we have minus k g t divided by r divided by r. Okay, so if we calculated these integrals, we can substitute them into our differential equation, and after substitution we will obtain that omega minus omega 0 is equal to minus k g t divided by r. And at last we have that omega is equal to omega 0 minus k g t divided by r. Okay, do you have any questions about this? Do you have any questions about this? No questions. No questions. Okay, if there are no questions, I will remove unnecessary things from the screen. I will remove things that we don't need to anymore. I will remove them, and I'll leave just things that we'll need. Okay, we don't need this, but we need only this result. We need only this result. Only this result, and from here we have so we have obtained oh, sorry, we have obtained a few velocities. We have obtained a few velocities, and we have obtained moment of inertia of the cylinder, and we can say that VR I remove this, but we need this velocity. It was omega r. You must have this in your notes. And from here we have that VR is equal to omega 0 r minus k g and t, but not kgt. It was 2 kgt minus 2 kgt minus 2 kgt. Why this 2 occurred? Because we had equation of dynamics before. We had equation of dynamics, and from here we had that mr to the power of 2 divided by 2 d omega by dt, and this was equal to minus k g t r, kgtr. And of course from here we had by dt, and it was not kgt divided by r. It was 2 kgt divided by r. So I have forgotten to write this multiplier 2. So from here we have this solution. Here we have this solution. Sorry for this mistake. Okay, and what can we say? What can we say from here? From here we have that if there are no slippering, velocity of slippering will be equal to 0. Velocity of slippering will be equal to 0 when slippering ends. And from here we can find that V is equal to VR. V is equal to VR. Okay, and we can substitute V into here and VR into here, and we will have that kgt is equal to kgt is equal to omega 0 r minus 2 kgt. 2 kgt. 2 kgt. And from this equation, we can get time of slippering. Time of slippering, it is equal to omega 0 r divided by 3 kg. Okay, this is the answer. This is the answer for the first part of the exercise. This is the answer for the first part of exercise number 12. Do you have any questions about this? No questions. No questions. Okay, if there are no questions, I will remove some unnecessary things. And now let's try to solve the second part. Let's try to solve the second part. In second part, we have to find the work of force of friction that acts on the cylinder. The work of force of friction that acts on the cylinder. Okay, how to do this? Maybe the simplest way to do this is the work energy theorem. According to this theorem, the sum of kinetic and potential energy in final position minus sum of kinetic and potential energy in initial position is equal to work of non-conservative forces. We have only one non-conservative force in our system. This is the force of friction. So A will be the work what we need to find. A will be the work what we need to find. Okay, and what about potential energy? In our system, we don't have any changes. We don't have any changes in height. We don't have any changes in height of the cylinder. So height of this center mass of the cylinder remains the same, and there are not any deformations. There are no deformations. And because of this, we can conclude that potential energy in second and first moment in time, they are equal. So because there are no changes in height of the cylinder and there are no deformations, so work of the force of friction is equal to difference between kinetic energies in final and initial positions. Okay, and the only thing we have to do next is to find these kinetic energies. Maybe you can remember how to find kinetic energy in case of planar motion. of perfectly rigid body. How to find kinetic energy in case of planar motion of perfectly rigid body. No ideas. No ideas. Kinetic energy is, in this case, is sum of kinetic energy of linear motion of the center of mass. So it will be m multiplied by squared v divided by 2 and plus rotational kinetic energy, moment of inertia I, omega to the power of 2 divided by 2 and minus, and in first case, in first position and at initial moment in time, we have only angular velocity. We don't have velocity v in at initial moment in time. So we have I omega 0 divided by 2. Okay, so the first what we need to do is to find v and omega. Is to find v and omega. So let's use this time that we have found before. So after substitution, we will obtain that it is equal to omega 0 r divided by 3. And the similar situation, will be with angular velocity. With angular velocity, we will have omega 0 minus, after simplifying, minus 2 omega 0 divided by 3. And this will be omega 0 divided by 3. Is omega 0 divided by 3. Okay, and what is the next? What is the next? The next step is to use these velocities and moment of inertia of the cylinder. Moment of inertia of cylinder here. Okay, after substitution, we will have m divided by 2 omega 0 r divided by 3 and to the power of 2 plus moment of inertia m r to the power of 2 divided by 2 omega 0 divided by 3 to the power of 2 and minus mr to the power of 2 divided by 2 omega 0 to the power of 2. Okay, and let's simplify. Let's simplify this this relation. Let's simplify this relation. So I can write outside of the brackets m r to the power of 2 omega 0 to the power of 2 divided by 2, and in brackets we will have 1/9, then we will have sorry, I have forgotten because I have forgotten to write 1 second in front of these terms, because we have 2 in denominators here. So it will be plus 1/18 and minus 1 second. Minus 1 second. From here, we have m r to the power of 2 omega 0 to the power of 2 divided by 2. And it will be 2 plus 1 minus 9 divided by 18. Divided by 18. Okay, and after simplifying, at last we have mr to the power of 2 omega 0 to the power of 2 and divided by 6. This is the work of the force of friction. Okay, it is the answer. It is the answer on the second part of the exercise. Okay, do you have any questions? Do you have any questions? No questions. Okay, if there are no questions, the next homework will be exercise number 13. The next homework will be exercise number 13. It will be the next homework. And it is necessary to say that I still haven't obtained any homework from you. I still haven't obtained any homework from you. So I think it is necessary. It is necessary to do them. It's necessary to do them if you want to have a good grade at the end of the semester. Okay, do you have any questions? No questions. Okay, if there are no questions, so thank you for your attention, and I hope to meet you next week.